So now that we've talked about multivariate regression with an example, and we've kind of visually described what we're trying to achieve with regard to designing the best line through a multi-dimensional space, and remember, again, what we're going to classify as the best line is one that minimizes our squared errors, and we're going to call those residuals. These residuals or errors I'll denote as E, and each observation, right, is going to have some deviation between what we observe and what we predict, so what the regression line is for that value of x or multiple value of x's. So we can again rewrite our residuals as what we observe minus the predicted regression line for that value of x. And again, what that's going to look like is, for our example with one variable of Q2 growth, we'll fit our regression line, and then we'll have a absolute deviation from that fitted regression line and what we actually observe. Now, all we're doing is that exact same thing, but in a multi-dimensional space when we add in our additional covariate. Now, before I jump into the nitty-gritty of actually figuring out what estimators we're going to use and how to estimate a regression from that, I just want to briefly walk over the goals of what we're trying to achieve when we're estimating a multi-dimensional linear model. So remember that on average, we think that the world looks like this, where our expectation of y, or the mean of y, is going to be equal to that estimated regression line that we have. Now, what we have in order to estimate that relationship is data, and we know that that data looks like our outcome, and we have that index by each observation, and we estimate that that relationship looks like our regression line, where we have an intercept and we have our x1, and now through x2, x3, we can add on as many covariates as we want. But importantly, our model is going to incorporate some error or uncertainty, right, between what we observe and what our model predicts. Now, again, importantly, we're going to carry forth that assumption that we had before, that on average, our errors or residuals should equal 0. They should be centered normally around 0, and they should have a variance of sigma squared. And again, what we're going to have to do is we're going to have to choose the best rule to find what is the best estimate of those parameters that we're interested in. So we're going to need to find the best estimates of our intercept, of that variance, and of our betas for all of our covariates. So before I jump into how we're actually going to find the best estimators of those parameters, I'm going to walk through briefly some basic linear algebra notation as well as functions. And so if you feel comfortable with that material, you can go ahead and skip ahead 2 videos. And if not, if you need that primer, please just continue on as normal.